Okay, yes, Zara. Am I audible, Zara?
Yes, ma'am.
Okay. So we were studying drift velocity in current electricity. So basically what had been seen in drift velocity, that drift velocity was the velocity which was the average thermal velocity, where all the charges are drifted towards the positive terminal. And we had seen the formula also, minus EE tau by M. Now, few things here we have to see in drift velocity, which we couldn't complete it in the last class. One thing, there's a relationship of drift velocity with temperature. See, temperature increases, your average relaxation time decreases. So drift velocity is directly proportional to the average relaxation time. You can see VD is equal to minus EE tau by M. So tau is directly proportional to velocity. So velocity and tau, they are directly proportional to each other. So when temperature increases, the relaxation time, this will decrease because very fast the collision will occur. Thermal kinetic, basically the thermal energy increases, which increases the kinetic energy. So bodies which were slowly colliding and then separating, then colliding, then separating. Now, because of increase in temperature, increase in kinetic, they are quickly colliding. So if they're quickly colliding, it means very short period of time is there. So therefore, the average relaxation time decreases. And see, since the average relaxation time and drift velocity are directly proportional to each other, so drift velocity also decreases. And exactly opposite happens in case of when the temperature decreases. Then average relaxation time increases, drift velocity. So I've just written it in one line. You can write it properly in your words in your notebook. What you will write that when the temperature increases, the thermal energy increases, kinetic energy increases, and since the kinetic energy increases, bodies move quickly, which reduces the time. So average relaxation time decreases, and since average relaxation time and drift velocity are directly proportional to each other, drift velocity also decreases. And vice versa occurs in temperature decrement. This you will write, and wherever you will get stuck while you are writing, you will just tell me after this point what will come. Okay, because it's not mentioned on the screen and you should have the explanation because the questions come from this portion. Okay, now the relationship between current and drift velocity. This is a very important derivation and a very important question. This question comes from your, more, this question has a frequency more than your previous question, like your previous derivation of drift velocity. There's an entire derivation of drift velocity which we have seen. This derivation, that is the relationship between current and drift velocity, this is much more important than that. Though this is very short, drift velocity was very lengthy. But since this is short and has a very important formula hidden and it relates current with drift velocity, means your drift velocity is now connected to the chapter. That's why this is very important derivation. So basically we'll take conductor. Now when we draw like this, when I have drawn like this, it means we have taken a wire only. We have cut the wire and now this portion which we have got, we have expanded it so that we can see things which are present inside clearly. Now, here the length is L. Okay. Now, if I am calculating the time, what is the time? See, you know speed is equal to distance divided by time. So can you tell me, Zara, from here, what will time be equal to? V is equal to S by T. So what is T equal to?
V into S.
T is equal to
V into S.
V plus
No, V into S.
V into S. No? See? See the formula? V is equal to S by T. So T should be equal to
S by V.
S by V. This
Yeah.
will be here This will come here. So distance
Hmm.
upon time. What is the distance? Distance is the length. What is the speed? Speed is the drift velocity. One equation which you have. Okay. Now let's talk about the charge. Let's talk about the charges. So here electrons are present. Now, there are so many electrons which are present. There are so many electrons. So what we are going to do, we are going to multiply every electron to its volume. We know the volume here is A into L, correct? So if n number of electrons are present, see how do you calculate current? You calculate current by charge divided by time. So if n number of electrons are present, so total charge will be n into A into L into E, means n times you will multiply it. One electron, now n number of electrons, so you will multiply it. So this is the second equation, and you know current is equal to charge by time. So let's put it. What is the value of charge? Charge is NaLe. What is the time? L divided by Vd. Vd will go up. L will be cancelled. What is the formula of current? NeaVd. This is the formula of the current in relation with the drift velocity. Means what do you have over here? I is the current. N is the number density. Number density means number of electrons which are present in a unit volume. This is the electronic charge, 1.6 into 10 to the power minus 19. We call this as the electronic charge. A is the area and Vd is the drift velocity. Okay, it's a very important relation. Write it down first. First write down this part, then this.
Ma'am, I wrote this. Can you scroll down? Ma'am, can you scroll down, please? Done, ma'am.
Okay, now we'll see one relationship. See, if you look at this, I is equal to NEAVD. So one question for you, Zara. If current increases, what do you think will happen to the drift velocity?
I feel like it is proportional to it, current and drift velocity.
Yes, so by the formula, we can say current is directly proportional. But see, here is an exception which you have to remember. Though when you look at the formula, it appears that current is directly proportional to the drift velocity. So they should be equal, but current is independent of area of cross section. Okay. So what happens is that in this formula, current appears to be directly proportional to N. It appears to be directly proportional to E. It appears to be directly proportional to area and directly proportional to drift velocity. So if you look here, current is independent of the area. Why? Because whatever current will be entering will be the exact amount of current leaving. So that's why even if you have I1 greater than I2, here if we have I1 greater than I2, it's not necessary that we'll be having a relationship with area. But yes, you can say area and drift velocity are definitely inversely proportional from the formula. So current is independent of area of cross section. But if you look in this figure, this is a narrow end of the pipe and this is a huge wider end of the pipe. Current is entering, I1 is the end, A1 is the area, V1 is the drift velocity. I2 is the current, A2 is the area, and VD2 is the drift velocity. So current, if we can say A2 is greater than A1, this edge is greater than the smaller edge. So drift velocity 1 will be greater than drift velocity 2 because they are inversely proportional. So it is valid in this case, but not in case of current. For current, you have to remember it is independent of the area of cross section. Write down this point to make a note point and write down this page. Okay. So now there's an important law which is called as the Ohm's law. So what exactly is Ohm's law? Ohm's law is very easy law, but see, direct questions on Ohm's law are not asked. But the question on Ohm's law is very easy. You'll be able to relate it. You'll be able to understand the law, and you'll be able to directly answer the question which has the Ohm's law given. But the difficulty arises in the applications of Ohm's law. Starting from now till the last chapter, that is your semiconductors, you will be using and having the applications of Ohm's law. So what does Ohm's law say? It says that at constant temperature and pressure, current through a conductor is directly proportional to potential difference across its ends. Means temperature is not changing over a certain time, over a certain place. Pressure is not changing over a certain time, over a certain place. So what will happen? The potential will be directly proportional to the current. This is the Ohm's law. But what do we do in mathematics? In mathematics, you remove the proportionality sign and put an equal to, and a constant comes. So here the constant, that is resistance. So what is V? V is the potential difference. I is the current. R is the resistance. We'll be talking about resistance in a little detail because resistance is your separate topic. The next topic after this Ohm's law will be your resistance and resistivity only. So this exact statement, this is your Ohm's law. Now, if you plot a graph, see, V is directly proportional to I. It means you will get a straight line graph. You will get a straight line graph because they are directly proportional. So it means the slope of the graph will be equal to tan theta. And how can we calculate this tan theta? This tan theta is V divided by I, which is equal to the resistance. This is very important for you. One question is also there. This question you will write it. You will try it first by yourself, both the parts. First, at least one parts. Then only I'll discuss it. Take your time for this because after this, we just have the next topic. So write down this first. Ohm's law, first write it.
Ma'am, can you please scroll down? Ma'am, please scroll down.
Okay, so first you got as 1 by root 3 B as root 3. Let's check it. See, in the first example, the resistance of A. So this is I versus V graph. So resistance will be given by 1 by tan theta. If it was V versus I, then the resistance would have been through tan theta. So what will be RA? This will be 1 by tan 30 degree. So RA will be 1 by root 3 will go up. Answer is root 3 ohms. In the second case, RB will be 1 by tan theta B. So RB will be 1 by, this is root tan 60 degree. So this is 1 by root 3. So answer is 1 by root 3. So your answers A, now you see, because the graph was written as I versus V, the answers are different. Okay,
Yeah,
Zara?
I didn't notice that.
So this is I versus V graph, not V versus I. Write it. It's okay. Write it.
Okay. Done. Um,
Okay, so two things we have studied, two formulas already we have studied. V is equal to IR. From their resistance was V by I. Now we will be focusing on resistance one. We have studied Ohm's law. We have studied the introduction of resistance, and now we know what is resistance. So what we are going to do, we are just going to focus primarily now on resistance only. So our topic is resistance. So Ohm's law, R is equal to V by I. Now, let's come to the definition of resistance. What is meant by resistance? So, resistance is the opposition in the movement of electrons. Okay. Opposition in the movement of electrons means there will be a resistance, a barrier that will be provided when the electrons would be moving. Okay. Means electrons are moving, and in their path, in their motion, there is a rigidity and a resistance and an opposition that is felt in them in their movement. So the smooth movement is not so smooth because of the resistance. So why do we have resistance? Because you have to control the current. Okay, so this is what is meant by resistance. Now we have seen I is equal to NE A VD. This is the formula of the current. Now see, we have studied drift velocity is E tau by M. Let's put this value in drift velocity. So what will be the current? Current will be NEA. And instead of drift velocity, what we'll do? We'll put EE tau by M. Now let's do one thing. You know, there is one more formula of electric field in relation to the potential. Do you remember that formula, Zara? Can you tell me? Electric field and potential, are they related to each other? Any formula which you've seen, anything?
E is equal to V by L.
Correct. E is equal to, you must have heard E is equal to minus dV over dr. So this is
Yes.
basically, this is called the potential gradient. Electric field is a variant of potential gradient. Gradient means when something is changing with respect to time. So here we will write electric field is equal to V by L because the length of the conductor is L. Now if we put this N E square A tau and now V by L M. So look here. This is what we'll get if we substitute V. See, this is the formula. Now, if I write it in terms of V, I bring everything on the opposite side. So this is equal to ML into current divided by NE square A tau. Now look at this thing. Just notice one thing, Zara. V is equal to IR. Can you notice V is equal to IR, which is Ohm's law? Means the value of the resistance is this only which is left. So resistance is equal to ML divided by NE square A tau. This is the formula, one more formula of resistance. So three formulas we see. First one we have seen V is equal to IR. So from there R is equal to V by I. Second formula is this which I have written on the screen. Third we'll see later. What is R? R is the resistance. What is M? M is the mass of conductor. L is the length of conductor. N is the number density. E is the electronic charge. A is the area of conductor. You should know when it is conductor, when it is electron, when it is the charges. And tau is the average relaxation time. Is it clear till here, Zara? Any doubts?
No, ma'am. That's clear.
Oh, very good. Write it down. If you have anything to ask, you can start writing from here. Make the heading as resistance. Do not write resistivity right now. Just make the heading as resistance.
Okay. Ma'am is done. Can you scroll down? Done, ma'am.
Okay, now look, resistance depends upon four things. Firstly, resistance depends upon the length of the conductor. Then resistance is inversely proportional to the area of the conductor. Then it depends on the nature of material and temperature. These two are also very important, nature of the material and temperature. How nature of the material, and how will you understand that resistance is depending on the nature of material? See, this way, you will see that resistance is unique for every subject, every object. Like if it is copper, so resistance of copper has a fixed value. Like this, things are fixed. Okay. So resistance is a measure of the opposition to current flow in an electric circuit. SI unit is ohm. So this is what is meant by resistance. One more formula of resistance you will see, but later we'll see that. This should be very clear to you. These 2 points, this temperature portion, we'll be discussing it in detail. After discussing resistivity, we'll discuss this because this is a portion included. Write it down.
Done, ma'am.
Okay, now we will see the next formula of resistance also. See, as I have discussed and you have written also, resistance is directly proportional to the length. Resistance is inversely proportional to the area. So resistance is directly proportional to length by area, correct? Now, if again you have to put a constant with L by A, so the constant that comes here, this is rho L by A. This is the third formula of resistance that you will be coming across. So what is R? R is the resistance. What is rho? Rho is a new term which is known as resistivity. So what exactly is resistivity? Resistivity is basically, see, resistance into area by length. Means resistivity is the resistance when area is 1 meter square and the length is 1 meter. So if a conductor is there whose area is 1 meter square, length is 1 meter, and the resistance offered is R. So resistivity will be equal to R. Resistivity is the resistance offered by unit meter area. See, resistivity of a material is defined as resistance of a material of unit length and unit area of the cross section. Okay, this is what is meant by resistivity. So see, resistivity is what? R A by L. So, and what was the formula of resistance? ML by A and E square tau. So if we put this here, rho will be equal to ML by A and E square tau into A by L. So area will be cancelled, length will be cancelled. So resistance formula without area and length, M by N E square tau. That's it. This is the formula of resistivity. And see, if you put the units, resistance is ohm, area is meter square, length is meter. 1 meter will be cancelled. Ohm meter will be the SI unit. This is what is resistivity. Write it down from here.
Ma'am, can you scroll down? Done, ma'am. Done, ma'am. Done, ma'am.
See, Zara, one thing I'll tell you about resistivity first, then you can practice resistance. See, length of the wire is increasing by 2%. In the formula of resistivity, we have already cancelled area and length. Means if you increase the area, if you decrease the area, if you increase the length, if you decrease the length, there is no area or length in the formula of resistivity. So resistivity will remain same. It is independent of the length. It depends on the material. Okay? Okay,
Yes,
Zara,
ma'am.
clear?
Yes, ma'am.
Okay. Write it. Resistance will definitely change. That we see. That first write down. And
Okay.
try for resistance.